Okay, so this lesson focuses on the section that's called Fundamentals of Probability. And so basically, we're going to talk about mainly in this part theoretical probability, but in general, probability, and this is in Canvas. So what is probability? So in math, the probability is a branch that deals with the likelihood of the occurrence of the given event. The probability value is expressed between the range of numbers from 0 to 1. All right, so basically what that means is that, and you talk about probability all the time, so what are the odds, what's the probability, and so on. So if you have, just in general, I'm going to go ahead and do this horizontally right here. So let's say that this is our possible values of probability. Possible values of probability. Okay, and let's say this is 0, because remember it says it goes from 0 to 1, and you're going to see that's going to be true. Everything we do in terms of probability will be between 0 and 1. The value between 0 and 1. We're going to have decimals, we're going to have fractions, and so forth, but it will be between 0 and 1. Okay, so if you have a probability of 0 or 0%, what that means is that the chances of that happening is unlikely. Impossible. Impossible. Okay, impossible. If it's at 50%, okay, 50%, sometimes as a fraction it's 1/2, then it's a 50-50 chance. 50-50 chance. Okay? If it's somewhere between 0 and 50%, somewhere in that area, then we say that it is unlikely. And if it's at 1, then we say that, so if you have a probability that it is going to occur, it's 100%, or 100%, then we say that it is a certain it's going to occur. And then anywhere between 50% and 1, we say it is likely. Okay, so again, so when we do these, the theoretical probability and the empirical probability in part 2, you're going to see that all these probabilities will lie between 0 and 1. So just remember, if it's 0, then it's impossible. It will never, ever, ever occur. If it's probability 1, then it will occur. If it's 50% or 1/2, there's a 50-50 chance it's going to occur. Anything between 0 and 50% is unlikely. Anything between 50% and 100% is likely. Okay? All right, so there are going to be two kinds of probabilities we're going to talk about in this section. One's called theoretical probability, and the other one's called experimental probability. Sometimes the experimental probability is called empirical probability. Okay? Sometimes called empirical. All right, so theoretical probability, let's talk about that definition first. So theoretical probability is a theory behind probability, so the idea of theory. To find the probability of the event using theoretical probability, it is not required to conduct an experiment. So instead of that, we should know about the situation and then find the probability of an event occurring. So basically, in theoretical, there's no experiment occurring. You're going to see that in the part 2, they're going to be experiments, and you're going to see what that's going to look like. Okay? All right. So let's talk about some definitions, though. All right. Suppose we have a coin, and I had a coin here, and you know that in football they always toss a coin, and so you have your heads, and then on the back part on the other side you have your tails, right? So heads and tails. So when you flip a coin, when you just flip it once, then there's only, it's either going to show up tails or heads, right? When you flip a coin, you're either going to get heads or tails. Y'all agree? Okay. So in terms of, and sometimes we'll denote heads as capital H and tails as capital T. Okay, so as we talk through some of this, we're going to use the word sample space. So let's talk about what we mean by sample space. Sample space. So the all the possible outcomes. So the sample space consists of all possible outcomes. Okay, outcomes. So the sample space consists of all possible outcomes. All right, now what that means is this, and here's how we denote it. So we denote sample space with a capital S, and we say, and it consists of a set, so we'll say it consists of the set. And in this case, when I flip a coin, I either get what? Heads, and what's the other one? Tails. So that would be my sample space. So the sample space for flipping a coin is either heads or consists of heads and tails, right? Okay. Now, let's talk about the word event. All right, event. So we denote we denote an event. So an event, which is denoted as E, capital E, is any subset of the sample space. Is any subset of the sample space. All right, so an event is any subset of the sample space. Okay, so for example, let's suppose I had this. Let's say the event is this. Okay, let's talk about what that means. So what that means is this. So this right here is the event. Of landing heads up, right? So H, heads lands up, tails hands up, right? T, tails hands up, lands up. Okay, so this right here implies the event that heads will land up. All right? Okay, now, so if I look at this right here, so this sample space consists of how many outcomes? How many outcomes do you see? There are two, correct? You either get heads or you get tails. And the event, so the event I'm looking at is this, the event that heads will land up. Okay? All right, so in terms of probability, when you see something like this, probability of E in this case, what that means is probability of this event. Probability of this event, and the event is this. Or I could say probability of H. So probability of H meaning, what's the probability of heads landing up? All right? So let's talk about how to compute the theoretical probability. Computing theoretical probability. All right, let's talk about computing theoretical probability. All right, if an event, EVENT, has equally likely outcomes, all right, so let's talk about equally likely. So do y'all agree that when I tossed a coin, I would either get heads or tail, and it's the same likelihood of getting heads or tails, right? There's nothing favoring heads, there's nothing favoring tails. I either get heads or tails. All right, so that's what we mean by equally likely. So if an event has equally likely, and let's call the event E. So if the event E has equally likely outcomes, and its sample space has equally likely outcomes, okay. All right, so if an event has equally likely outcomes and its sample space has equally likely outcomes, let me go ahead and try and focus this a little. All right. then the theoretical probability of event E is denoted by probability of E, just like we had here, probability of E, which is, okay, listen carefully, which is the number of outcomes in event E divided by the total number of possible outcomes. All right? So the total, so probability of event E occurring would be the number of outcomes in event E divided by the total number of possible outcomes, which would be your sample space. All right? So let's look at this. So let's go back to our example. So remember we had earlier the event was heads. What's the event was head? The event that of heads landing up, right? Landing heads up. So the probability of E in this case, probability of E would be, all right, so in this case, how many heads do you see? You only see one, right? So that'll be 1 divided by the total number of possible outcomes. So what could happen when I flip a coin? I can either get heads or tails. How many do you see? 2. And so that'll be your answer. So the probability of heads landing up is 1/2. It kind of makes sense, right? Theoretical. So how many sides do you see? 2. So when I flip it, either heads lands up or tails lands up, right? So each one has the same probability, 1/2 each. Okay, so let's look at another example. All right, so in this example, we're going to be rolling a die. All right, rolling a die. All right, so remember what a die looks like. Let's see if I can find a picture of one. I don't have a physical one with me, but I think you all know what a die looks like, right? So this would be dice. Dice means plural. A die, D-I-E, means singular. So this would be dice. All right. So notice, though, in particular, that on a die, each side has a certain number of dots. So there are 6 sides to a die, right? So you have either 6 dots, 5 dots, 4 dots. On the other side, you have 3, then 2, and then 1. Okay? All right. So in each side, you have dots going from 1 to 6. So just keep that in mind. Okay, so notice, let's talk about the die. So do y'all agree that when I look at a die and I roll it and I roll a die, if I were to roll it, do y'all agree that either I'm going to get 5 or 6 or 4 showing up, right? Okay, facing up. So the sample space will be either I get a 1 showing up, I get a 2 showing up, I get a 3 showing up, a 4, 5, 6. So y'all agree that's a sample space? All right. Now, so let's look at an example. Okay, so a die is rolled once. A die is rolled once. All right? Find the probability of rolling a 2. So let's talk about the probability of rolling a 2. So if I roll a die, if I roll one die and I roll it, how many 2s are on all those sides? They're just 1, right? So you just have 1. All right. So in terms of our definition for probability of an event. So in this case, the number of outcomes in event E. So the event is I want to roll a 2, right? That's my event. So keep in mind, your event is I want to roll a 2. How many 2s are in here when you roll it? There's just one. So the event of rolling a 2, so the probability, and let's just write it as probability of 2. Probability of 2 would be, what's the number of outcomes in event E? So when I talk about the number of outcomes to get a 2, there's only one, so that's going to be up here. And then what's the total number of possible outcomes? Total number of possible outcomes is 6. 1, 2, 3, 4, 5, 6. So there's your answer. So the probability of rolling a 2 is 1 out of 6. Okay? All right, so it's letter A. Letter B, what's the probability that when you roll it, it is an even number? So the probability of rolling an odd. Let's do an odd. Odd number. Okay, probability of rolling an odd number. So rolling an odd number, so that's my event. So I want to know what's the event. So my event is that I want to roll an odd number, right? So let's find the probability of rolling an odd number. Let's do it like that. We'll just write it like that. Okay. So remember, the event is I want to roll an odd number. Rolling an odd number. So the numerator is the total number of outcomes in the event. So how many odd numbers do I have here? Well, there's 1, 3 is an odd number, and 5 is an odd number. So how many outcomes are there in rolling an odd number? Well, there are 3 of them. How many possible outcomes are there in my sample space? Total number of possible outcomes. Well, there are 6. So I reduce it, I get 1/2. All right, so the probability of rolling an odd number is 1/2. Kind of makes sense because you have 3 odd numbers out of what? 6. And you have how many even numbers? 3. All right, so 3 odd, 3 even. So it's 50-50. Y'all agree? All right. C, what is the probability of rolling a number less than 4? Less than 4. So probability of rolling a number less than 4. All right, well, so the event is I'm rolling a number less than 4. So let's talk about the probability of less than 4, rolling a number less than 4. All right, so how many numbers, so how many numbers are in my event less than 4? Now remember, less than 4 does not include 4. It does not say less than or equal to 4, right? It only says less than 4. So is 1 less than 4? Yes. Is 2 less than 4? Yes. Is 3 less than 4? Yes. Is 4 less than 4? No, it's equal to. So there's only 3 of them. So you're going to say 3. And how many possible outcomes are there altogether? 6. So again, that's 1/2. All right, D. What's the probability of rolling a number less than 8? What's the probability of rolling a number less than 8? All right, let's talk about that. So my event is rolling a number less than 8. How many of these is in my event, rolling less than 8? Well, all of them, right? 1, 2, 3, 4, 5, 6. So if I want to look at the probability of rolling less than 8, so if I roll a die, will I get a number less than 8? Yes, always, right? So that would be 6 divided by 6, which is 1. Remember, 1 means it's going to happen. So the probability of rolling a die less than 8 is 100%. Because there's no 8 on there, right? There's no 8. It goes from 1 all the way to what? 6. Okay? All right, so that's 1. All right, what about this? What's the probability of rolling a number greater than 7? Greater than 7. All right, so that's my event. So in my event, how many outcomes are there in my event? So how many of these numbers are greater than 7? 0. It kind of makes sense because if you roll a die, are you ever going to get a number greater than 6? No. So you're going to get a number ever greater than 7? No, you won't. So in terms of actually doing the work, you're going to say something like this. Probability of greater than 7 is going to be equal to, now how many, in my event greater than 7, in the event greater than 7, how many of these numbers are greater than 7? 0. Divided by the total number of possible outcomes. How many outcomes are in my sample space? 6. And what's 0 divided by 6? 0. So that is impossible. So you will never be able to get these events. So the event of rolling a number greater than 7 is never going to happen. The event of rolling a number less than 8 will always happen. Okay? All right. Now, let's look at another situation, another example. Okay, so in this example, we're going to look at rolling 2 dice, rolling 2 of them. So here's my sample space. Now remember, I'm rolling 2 dice, right? I'm rolling 2 of them. So I want you to notice when I roll 2 of them, you see how in this case I can get a 6 and a 5? Y'all agree? 6 and a 5? All right. So the way we're going to do this, though, is this. So this would be my first die, and this would be the second. Okay? And so when I roll the first dice and I get a 1, I can roll the second dice and get a 1 too, right? So you see 1, 1. So this one corresponds to the first dice. So they're kind of listed as an ordered pair. An ordered pair. And so notice, first of all, in this sample space, how many outcomes do you see? 1, 2, 3, 4, 5, 6. And then 6 here, so that's 36, right? 6 times 6, 36. So there's 36 outcomes in my sample space. All right, so again, let's talk about what this 2, 3 means. 2, 3 here means that on the first dice, I rolled a 2, and on the second one, I rolled a what? 3. What does the 5, 4 mean? On the first dice, I rolled a 5, and on the second one, I rolled a 4. What does 5, 6 mean? On the first, I rolled a 5, and on the second, I rolled a 6. All right? Okay, so keep that in mind. Okay, now, let's look at this example. So we're going to come back to this. So notice this is my sample space. Just make sure you know how to read this ordered pair. All right. Okay, so let's do this example. Okay, so in this example, let's suppose, let's see real quick. All right, so what's the probability of getting? So remember, this is the one with rolling 2 dice. And then remember your sample space. So all this, this handout is in Canvas. So if you need to look at it, go ahead and print it out in Canvas. Okay, so rolling 2 dice. Okay, find the probability. Find the probability of getting a 2 odd numbers. 2 odd numbers. That's my event. So remember, to find the probability of getting 2 odd numbers, remember I want to find the probability of 2 odd numbers, right? So if I want to find the probability of getting 2 odd numbers, my event, I got to look at my sample space and see how many of these have 2 odd numbers. So here's 1. Here's another, right? 2, 3. Well, obviously, okay. So let's do this strategically. So a 2 here would never work, right? Because that's even. So I can cancel out 2, 4, and 6. Y'all agree? All right. Now let's look at row 1. So row 1, dice 1. That's 1, 2, 3. Let's look at 3. 4, 5, 6, right? Let's look at 5. 7, 8, 9. So remember I wanted two odd numbers. So I wanted an ordered pair that was odd, odd. Y'all agree? Odd, odd. That's what I wanted. So odd, odd. So there's odd, odd. There's odd, odd. There's odd, odd. So that's 3. Here's another odd, odd. Another odd, odd. Another odd, odd. Y'all agree? So 3, 6, 9. So you get 9 possibilities for that event divided by, and how many total are there? 36. And if I reduce, that's 1/4. Okay, so what's the probability of rolling two odd numbers? 1/4, or 25%. Okay, part B. All right, let's get to part B. What's the probability of rolling two numbers whose sum is, let's say, 7. Two numbers whose sum is 7. All right, so we look at this. So I need two numbers whose sum is 7, right? Okay, so let's start with 1. 1 plus what is 7? 6. Now, you agree that this will work? So there's one of them. So let's look at our outcomes for that event. Sum is 7. So I can get a 6, 1, right? So that's one of them. Let's look at 2. 2 plus what is 7? Well, 2 plus 5. So I have a 5, 2. Y'all agree? 5, 2. Let's look at 3. 3 plus what is 7? 4. And you see these kind of look like a diagonal, right? 6, 1 is 7. 5, 2 is 7. 4, 3 is 7. What's the next one? 3, 4. What's the next one? 2, 5. What's the next one? 1, 6. So it's kind of like in that diagonal right here. So 5, 2. 4, 3. 3, 4. 2, 5. And 1, 6. Okay? So how many of these do I have? 1, 2, 3, 4, 5, 6. So the probability of sum 7 is going to be 1, 2, 3, 4, 5, 6. So 6 divided by how many are there altogether? 36. So that's 1/6. So the probability of a sum of 7 is 1/6. C, let's look at the probability of two numbers whose sum exceeds, let's say, 13. Oops. Okay. Let's do 12. Two numbers whose sum exceeds 12. Well, in order to get 12, obviously I can't use 1 because 1 plus what is 12? 10. And it only goes up to 6. Can I use 2? Nope, because 2 plus what is 12? 10. Right? Can I use 3? 3 plus what is 12? 9. 4 plus what is 12? 8. Doesn't go up to 8, right? It only goes up to 6. So it looks like the only one that would work, well, what about 6 plus 6? Yeah, 6 plus 6 is 12. But remember, it says what? Exceeds. So exceeds means greater than 12. Keep that in mind. So will any of these pairs ever give you a sum that's bigger than 12? No. So that's going to be, so probability of greater than 12 will equal 0 divided by 36, which is 0. So that's impossible. It's not going to happen. Okay? All right, what about this one? Two numbers whose sum is less than, let's say, 9. Two numbers. Well, actually, let's do this. Let's say less than 15. Two numbers whose sum is less than 15. Well, again, let's think about this. In order to get 15, can I use 6 and 6? No, because what's 6 and 6? 12. And all these will be what? Less than 12. Okay, so two numbers whose sum is less than 15. Oh, it's less than, right? Okay, sorry, less than. So less than. I was thinking greater than. So less than. So are all these numbers, when you add up all these numbers, when you add them up, less than 15? Yes. So what's the probability? What's the probability of that event happening? Okay, so you're going to say probability of less than 15 will equal 36 divided by 36, which is 1. Because all those numbers, when you add them up, all those pairs, when you add them up, is less than 15, right? So how many are there? 36. How many total outcomes in your sample space? 36. So 36 divided by 36 is 1. Okay? All right, let's take another example. Okay, so this example is going to deal with a spinner. And so notice that you have, and each little area is the same. Okay, so each of these little pies, let's say, has equal probability, equal likelihood of this spinner landing on it. Notice how many yellows do you see? 2. How many reds do you see? 2. How many greens do you see? 3. And how many blues? Just 1, right? Okay. So remember that each one has the same likelihood of occurring. Okay? All right. So let's look at a probability for that one. So this will be the one on the spinner. Example, spinner. Our colored spinner. Okay, 1. Find the probability. Find the probability that the spinner lands in a, let's say, a blue region. Okay, blue region. All right, well, so my event is I want a blue, right? How many blues do you see? Just 1. Just 1, right? Okay, so the probability of blue will equal 1 divided by. Now, how many of these do you have? Don't just count red, yellow, green, and blue and say that's 4. Remember, you have yellow, you have another yellow, you have 3 greens, and you have 2 reds and a blue, right? So how many are there altogether? So your sample space, if you want to look at this in terms of your sample space, you will say green, look, green, how many greens do you have? 3. So green, 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 2 yellows, right? And then 2 reds, and then a blue. So how many are there altogether? How many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. So it's 1/8. All right. B, what's the probability of getting a, let's say, a yellow region? Okay, so how many yellows do you see? How many yellows do you see? 2. So the probability of yellow will equal 2 divided by, how many are there altogether? How many regions? 8. That's 1/4. C, what's the probability of getting a, let's say, green? Probability of getting a green region, green. So how many greens do you see? 3, right? How many are there altogether? 8. So 3/8. Okay. D, what's the probability of that the spinner lands in a region that is red or yellow? Red or yellow, okay? So now I have 2 colors. So I want either red or yellow. How many reds do you have? So my event is red or yellow. So how many reds do I have? 2. How many yellows do I have? 2. So that's going to be probability of red or yellow. Red or yellow. R or Y is 4 divided by 8, which is 1/2. So remember that was 2 yellows and 2 reds. Okay? So remember there were 2 of those and 2 of those. E. All right, let's look at E. What's the probability All right, let's say region that is green or yellow. Green or yellow. All right, so probability green or yellow equals, how many greens are there? 3. How many yellows are there? 2. So how many altogether? 5. So it'll be 5 divided by 8. So there were 3 greens, 2 yellows. Okay, F. What's the probability that the region is yellow and red? Yellow and red. So I want this thing to land in a region that is yellow and at the same time red, right? So notice the word and. So this is the word or, this is the word and. So is there any region that's both yellow and red? No. This region is just what? Green. This region is just what? Yellow. This region is just what? Red. This region is just what? Blue. This region is just what? Green. This region is yellow, and so on. So this event, the region yellow-green, is that an impossible event? Yes, that's an impossible event. Impossible event. So what's the probability of yellow and red? What are you going to say? If it's impossible, you say what? 0. It's not going to occur. That's an impossible event. Okay, and then, all right, so any questions on that? So I ran out of room here, so we'll stop there. The next thing we're going to look at in the next example, and I'll stop here with the video, but the next example will be looking at a deck of cards. All right, so most of you know what a deck of cards look like. Maybe a couple of you may not, but this is in Canvas. So before we do that, before you go to that part 2 of the theoretical probability, make sure you look at this diagram. All right, so that's the end of this lesson.